Rajasekar from Engineers India Limited. He will discuss the need for utilization of C&D waste in the modern construction industry. Engineer R Rajasekar has around 15 years of consulting experience for various projects in India. He started as a field engineer and is presently working as a lead engineer, overlooking the project management of all kinds of civil structures, UG piping works for a refinery and petrochemical complexes. As lead over 15 years in oil and gas and infra projects, he has executed various projects covering areas such as units, offsite, plant buildings, water retaining structures, silos, tank pads, drinking and sewer networks, and road and drains across India. Also responsible for executing these projects by coordinating, managing, surveying, engineering, construction and commissioning activities. Let's welcome Mr. Rajasekar.
My topic is need for utilization of construction and demolition waste in the modern construction industry. Rather than I am saying this is a technical presentation, I can say this is an awareness program. So I want to create this awareness among our construction industry first of all. This is my brief insight. My slides, my presentation contains around 16 slides. I used to, this topic covers around 6 topics. This presentation covers around 6 topics. Before going to the topic, I want to say a brief introduction or a small introduction you can say. What is meant by construction waste? That's the debris or the waste which have been generated after demolishing of a building or during the due course of construction or called as a construction waste. This is a small introduction. And I'm directly going to the construction and demolition challenges. What are the challenges which we are facing right now? First of all, India is right now India is generating around 23.75 million tons of construction and demolition waste. This figure is somewhat around 2 years back. Right now, it may be around 2 to 3 times or more also. And out of which we are recycling only 1% only. In the Western countries or in European countries or in countries like America or Japan, they are recycling around 80 to 90% of the construction and demolition waste, and they are using in the future constructions. This is the second challenge. And third challenge, what I found is that there is a lack of awareness and the knowledge among our own people itself, how to dispose it, how to collect it, how to segregate it, how to transport. These are this small kind of things also we people are doesn't know. We just want this debris to be put it out of our sight only. So there is a lack of awareness is there. And fourth is that in our cities like Mumbai or Delhi or Chennai, there is already a lack of space is there. So we can't able to separate it in site itself. We can't able to segregate it as a wooden scrap or a brick debris or a concrete debris. We can't able to separate it. So there is a segregation place problem is there, and transportation problem is there. Transportation means where we have to transport. Local bodies are not being identified where we have to deposit this or where we have to dispose this scrap. These are the 4 challenges which I thought this we have to address first. These are the facts of the construction demolition waste. Regarding the construction demolition waste, our government of India has given a clear guidelines in the year 2016, and it came in the form of act also, the construction demolition waste, which comes under the Pollution Control Board under the Ministry of Environment and Forest and Climate Change. This act should be executed as a sub-act of the Municipal Solid Waste Management that should be executed by the urban local bodies. Urban local bodies means that corporations, municipalities, panchayat, that they have to take a lead on these particular issues. This is the legal aspects. When I am coming to the technical aspect, IS 383, that is the specification code for the aggregate, has also given a provision that we can use this recycled aggregate in our concrete as a replacement of the natural aggregates. When the recycled aggregates are called as RA, that is recycled aggregate or recycled concrete aggregates. And more or less in our government project also, they've taken a mandatory to use at least 10 to 20% in our municipal and government contracts. That means we are having a legal provision also. Next, we are having the technical provision also. And the fourth fact is that right now our researchers are going on how to use more than 25%, how we can able to replace this natural aggregate, whether we can able to increase from 25 to 40% by using this GGBS and fly ash along with the increased cement content. That also we can use in the high performance concrete. High performance concrete means with the concrete which grade more than M30, M40, M50. There we can use. This is the requirement. This is the annual requirement of the raw material for an Indian construction industry. This figure I have taken out from our union budget 2022 and 23. The cement we need around 380 million metric ton and steel of 50 million metric ton, and brick of 600 billion numbers, and natural aggregate of 400 billion cubic meter, and timber of 40 million cubic meter. That means all the cement, steel, bricks, and natural aggregates, we have to once again depend upon the natural resources only. One hand, we have to save the natural resources. Another hand, we are just wasting this demolition construction waste. Once we are started to recycling this, we can able to replace this huge quantity with at least some extent. For example, for natural aggregate around 400 million cubic meter, we are depend upon these rocks and the river beds. Once we started to increase from 30% or replacing this, means at least we can able to reduce from 400 million metric ton to 300 million metric ton of natural resources, so that we can able to save the mountains and river beds. This is the construction waste generation contributed by the top 7 cities of the India. Ahmedabad and Kolkata is contributing around 700 to 800, and Hyderabad and Chennai is contributing around 2000 to 2500, and Bangalore and Delhi is contributing around 3000 to 3700, and Mumbai is contributing more. Reason is Mumbai means it is always developing a city. We can't able to stop this development. This Mumbai means Mumbai, Navi Mumbai, and Kalyan. All 3 corporates are included. So Mumbai is contributing more from apart from the other cities. This figure we have taken out from the State Pollution Control Board of the respective states. This is the adverse effect of the construction waste. Usually what we are doing is we are just depositing, we are just want to clear this construction waste which are generated in our own site, and we usually deposit it in unauthorized area. Unauthorized area means, first of all, we are thinking about only the river beds along the rivers or along the roadsides, because that all the river bodies are getting affected, and this stormwater drain are getting choked during the monsoon time, and it is disturbing our traffic also. Second, which is having a great effect on the environmental, and which is changing the chemical properties of the top soils, and so the vegetations are also getting affected. Third is that groundwater also getting affected due to this unauthorized deposits. And fourth, that diminishing of the landfill area, where we want to actually use this landfill area, we are not able to supposed to use. Fourth is when we are going for a demolition, or when you are going for construction, or when you are going for removal of any debris, definitely there is a severe air pollution is taking place. In this photo also we can able to see, this photo I have taken from this our guidelines given by the Government of India. The first page of this photo speaks more a lot. In order to control this waste, this 3R system is effective we can use. This 3R means that reduce, reuse, and recycle. First of all, this collection of construction and demolition waste is very, very important at the site level itself. Site people have to get more awareness how to segregate this brick beds, this concrete debris, wooden scraps, steel scraps, cable scraps. Once they started to segregate at the site level itself, means that we can able to complete around 50% of our challenge, and we can go ahead. Second is transportation. Transportation means before collecting itself, we have to freeze where we have to transport this. Whether we have to go to scrap yard, or whether we have to go to a landfill, whether it go to a recycling plant, that we have to be get freeze. Third is once it is reached to the recycling plant, all the process will be get started. The recycling, once it got recycled, it is recycled into 2 manners. Once it's in a silt form or a aggregate form. That application we will see in the next slide. As far as this C&D waste plant in India, totally we are having 16 C&D waste plant. I came to through the ministry that around India is going to set around 100 and 150. Right now I came through the ministry that Ministry of Urban Development is going to set an 150 C&D waste management plan across the country, out of which around 20 is going to come in Maharashtra, another balance is going to be distributed equally to all other states. And these are the machineries which generally we use: the bucket, crusher, iron separator, screening, or mobile crusher unit. This mobile crusher unit also you can use in any small sites and all. There where demolition is going to place, any renovation is of a building or any expansion of a building where the repair works are extensively used, that the small mobile plants we can able to install. That then and there itself we can able to we can reuse. Once it got recycled, after it recycled, it is called as recycled aggregate or recycled concrete aggregates. It may not be equal to a natural aggregate, but around 70 to 80%, it can able to give the technical parameters are getting met. As per IS 383, there is given a separate provision itself for a recycling aggregate. Recycled aggregate means that the aggregate which are been get recycled from the bricks or masonry or a WBM. Concrete recycled aggregates are the aggregates which have been got from the demolished of RCC structures or a pile heads or the left out of the RMC plants or the demolition of old roads. That when we are recycling that particular structures are called the recycled concrete aggregates. This is the photographs of the natural aggregates, natural recycled aggregates, and natural aggregates, where they are having very similar properties. Then when you are figuring out this natural aggregate will have some shyness and it will have some sharpness and it have good impact. But once it got recycled, obviously the strength will reduce, but it not that much, and these colors will get somewhat muddy or a grayish color, and the strength wise we can able to replace the natural aggregates. This is the concrete recycled aggregates that we can able to use up to M30 grade concrete as per the right now provision. There we can able to replace around 30 to 40% of the natural aggregates. Where we can able to replace means that non-structural member of your housing sectors. Then a WMM and WEMM of your road. In roadworks we can extensively we can use, no issue. Apart from the bridges, we can able to use in the ordinary roadwork. In the drainage, gutters, walls or curbstone we can use. In CPWD also they have started to give some good provisions and they are allowing us to use it. And pedestal path, walkways and all we can able to use. And the pavement and paver blocks and parking bay. And the construction of boundary walls. Boundary walls is basically a non-structural member that will demark these boundaries only. There we can able to extensively use. Where we can able to 100% use means wherever the filling is going to take place. Where the PCC, plain cement concrete below the foundation, dry leaning concrete, where we can able to use 100%. With before we have seen the replacement of 30 to 40% or 25 to 30%. Here we can replace around 100% itself. For non-residential building like public amenities, the park areas we can able to use, or canal lining we can able to use extensively. For irrigation works, for lining purpose we can use without any doubt we can use, no issue on that. And filling of the embankment works. In the embankment works or in the bridges where the road approach is there also we can able to use. These are the utilities of the RC and RA. When I'm coming to the conclusion and discussion, right now we need a robotic method of collecting a construction waste management. That is, we are having the rules, we are having a system. That system have to get performed. Once it got performed, we can able to see a visible output. That is, we need a robotic method so that we can able to handle this C&D waste. Then installation of recycling plant. Each and every person who was involving in the construction should know where my debris should go and where it should reach and how it get recycled. Then how we can able to replace. That means we should know the recycling plant location also, and location also should be in a reachable manner. Then fourth point is the government and professional bodies should encourage and develop an awareness, so that once we got the awareness, means definitely we will start to use the less quantity of natural aggregate and we can use the already used aggregates. Fourth is the lead and GRIGA, where we are getting the ratings for the buildings. There they have to give more weightage, more credit points. Once the project got utilized around 20 to 30%, means they should be get highlighted everywhere, so the other persons, other builders or other construction engineers may also use it, so that they can able to say as a pride, I use this old content aggregate and I have been a part of the natural warrior. Third is a geoinformatics system. This is a satellite-based monitoring system. There is our ministry are working for that. What is the basic purpose is to identify how much of construction waste are being scattered in India. We can't able to the collection of data itself is a Herculean task for us. Once we got a geo-based information, we can able to identify where this material has been placed or has been deposited, unauthorized deposit, how we can able to collect, and more or less we can able to see what is the quality of the construction waste, whether we can able to utilize or whether we can't able to utilize that. The quality also we can able to find out. This is a new system which in another couple of years we can able to get it. This finally this recycled aggregate and recycled concrete aggregate, this chemical properties and physical properties we need further research also, how to handle and how we can able to replace it, how we can able to do a better polishing or better byproduct, how we can able to get it. For that we need a mechanical support also and theoretical support also we need. The next point is the 3R system, which I already told, that's the recycle, reduce and reuse, how we can able to use. And everybody from the construction person to the client, from the contractor to the labor, everybody should know how to find out this wealth out of a waste. This wealth out of waste is the main concept of this C&D waste. This everybody should make an awareness program. Then final point is collection of data, where we are getting this data collection is not done properly. Even urban bodies or corporation or municipal corporations are also not able to produce the correct figures. Why? Because nobody want to declare how much of quantity of debris we are going to generate. No, everybody is giving approximate quantity, but most of them are just hiding the data only. Once we have got a exact data, we can able to find out how much of construction waste management have been collected, waste are collected, and how much we have recycled, and how much we have been kept at the yard, and further way of alternative of source also you can able to find out. Final point is everybody is going towards a net zero. Every company has committed to reduce their carbon footprints and to save the nature. Our EL also has been working on that. We are also kept a target of net zero 2035. And we are also working for that. We need the cooperation from everybody, every corner of the world, every corner of the construction world have to work for this particular topic so that we can able to achieve this effective utilization of construction and demolition waste in our future projects. This topic is not only for today. In another 20 years or 40 years, we are going to face a very huge problem for this natural resources. For that, we have to step up today itself to find out a effective solution. Thank you.